Hello guys, today we'll be solving A-Level Physics 9702 May-June 2024 paper 2-3. Let's begin. One states that a drag force Fd acting on a sphere falling through a liquid is given by this equation, where r is the radius of the sphere, v is the speed of the sphere in the liquid, and this n-type thingy is a property of the liquid called the viscosity. Show that the SI base units of the viscosity are kg meters per meter per second minus 1. Okay, so again, as far as let's write the equation down. So it's going to be force equals this n-type thingy rv. I haven't wrote 6 in pi because they are dimensionless quantities. They do not have any units, so there is no need to write them down. Okay, so force is kg ms negative 2 equals, I need to find the units for this one. R being the radius is going to be in meters, and speed is going to be in meters per second. So it's going to be kg ms minus 2 is equals to m square s minus 1. So just divide that. So you will get kg ms minus 2 over m square s minus 1. You would end up getting kg m minus 1 and s negative 1. That's going to be the what you're supposed to show over here. Moving on, the sphere has a radius of 3 centimeters and falling vertically to downwards at a terminal velocity. The terminal velocity means all forces will be balanced, no resultant force will be there. Of 2 meters per second through the liquid, the drag force acting on the sphere is this 0.096 newtons. Calculate the viscosity of the liquid. Okay, so you have this equation that they have already given you in the above question. So you have the drag force, that is 0.096, and 6 pi. You need to find this viscosity thingy. Radius is 3 centimeters. You'll convert it in meters, and on that note, you will also write a speed. Pick your calculator. After picking it up, you'll just say 0.096 and then divide it by 6 pi, times it by 3 times 10 to the power negative 2, and then 2. Just plug it everything in the calculator. You will get the viscosity as 0.085. That's the viscosity that I'm getting. Okay, moving on to the next part. The sphere is shown in figure 1.1. On figure 1.1, draw and label arrows to represent the direction of the 3 forces acting on the sphere as it falls at the terminal velocity through the liquid. Okay, since it's moving in a terminal velocity, that means the forces will be balanced. Whenever something is falling like in the liquid, and definitely it's falling at terminal velocity, the weight is always going to be acting downwards. The weight is going to be acting downwards. There are 2 forces that will be acting upwards because the terminal velocity is in downward direction. That means the drag, or you can say the viscous drag, would be in the opposite direction. It's always against the motion. So viscous drag and then the upthrust. So upthrust of the liquid, yeah. So these are going to be the 3 forces that you're going to be marking. And on that note, there's going to be D1. So the density of the liquid is 920 kg per meter cube. Show that the upthrust acting on the sphere is 1 Newton. Okay, the formula for upthrust goes like this, rho GV. So upthrust, you have to find the density is 920. The gravity is going to be 9.81. As far as the volume is concerned, it's a sphere. So for sphere volume formula is 4 over 3 pi r cubed. You have the radius of the sphere, that's 3 centimeters. So 4 over 3 pi r cubed. I'm just going to write it over here as well. That's volume will be given by 4 over 3 pi r cubed. So remembering that, cube that as well. Just plug everything as it is in a calculator. So 9.81 times it by 4 over 3 times it by pi, and then 3 times 10 to the power of negative 2 and square that. So you'll end up getting 34. So the value of upthrust is not be 34. I think I've made some error over here. 1 second. So 3 to 9. Okay, cubed. Yeah, sorry, it's not 34. Rather, it's 1.02. Okay, so it's going to be equal to 1. So 1 newtons is going to be the upthrust. Okay, moving on. You're required to calculate the mass of the sphere. Okay, so mass you need to find, you have the formula that's W equals mass times gravity, and you do not have the weight. But since the object is moving in terminal velocity, definitely the weight is going to be equal to the sum of these two forces. You already have the upthrust, that's 1 Newton. So 1 plus the viscous drag that is given in the equation above in B part, that's 0.096. So plus 0.096. These two forces adding up together would be equal to the weight because it's terminal velocity. You need to find the mass. The gravity is going to be 9.81. So 1 plus 0.096, and then the answer should be divided by 9.81. The value for the mass is going to be 0.11 kilograms. So 0.11 kilograms is going to be the value of the mass. That's it for question number 1. Question number 2. So first part is going to be define the displacement from a point. So displacement is basically distance in a given direction. So you can say that it's distance traveled in a given direction or in a specific direction. So it's quite simple. We have discussed this in our IGCSEs and O levels previously. An object is projected vertically, or sorry, horizontally at a speed of 6 meters per second from a slope as shown in figure 2.1. The slope is at an angle of theta to the horizontal. Air resistance is negligible. The object lands on the slope a time of 0.71 seconds later and stop without rolling or bouncing. Determine the horizontal distance traveled by the object. Okay, so they're saying that there's an object, definitely it would have been projected. It's basically a case of half projectile. So it would have been projected and it came down. So first of all, they're asking you about the horizontal distance. As they have said, air resistance is negligible. Definitely the horizontal speed is not going to change. So we can use a speed equals distance over time. So the speed in the horizontal direction is 6. You do not have the distance, but you have the time, that's 0.71. So you just have to multiply them together and you would get the horizontal distance, and the distance is under 4.26. So distance is going to be 4.3 meters. My value is 4.26. So it's two significant figures is going to be 4.3. Okay. Second part, they're saying that determine the vertical distance traveled by the object. So if you're required to calculate the vertical distance, that means this distance that the object has traveled, how much, like the distance down it has traveled in the specific amount of time. So the distance traveled vertically, this distance, the distance of like going down, that distance you're required to calculate. So again, you can use S equals ut plus half at squared. Any equation of motion, but I think this is the one that is going to be used over here. So you need S. The initial vertical velocity is 0 because the object is not moving in the vertical plane. Initially, it's just moving in the horizontal plane. So it can be half at squared. So it's going to be 1 over 2. Acceleration, since it's going under the influence of gravity, that's 9.81. And the time they have already given, that's 0.71, and you have to square that. So 1 over 2, you are just required to plug in the values in the calculator. So 9.81 and then times it by 0.71 and then square that. You would get the value of distance as 2.47. That's 2.5 meters. That's going to be second part. Okay. In the third part, you're required to use your answers in B1 and B2 to calculate the angle. Again, it's quite simple. If you look at the horizontal part, they have traveled the distance of 4.3 meters horizontally. If you look at the vertical part, you have traveled the distance of 2.5, and you're required to measure this particular angle because these two angles are going to be equal. So this angle is you have to find out. So again, you can use a tan theta, just basic at trigonometric entities. So tan theta is going to be equal to opposite over hypotenuse. So this is going to be plug in the values, shift tan of 2.5 divided by 4.3. Your value is going to be equivalent to 30 degrees. So 30.1, I'll just write it as 30 degrees. So that's going to be your answer for the angle. Moving on. Calculate the magnitude of the displacement of the object from its original position. Okay. So as far as displacement is concerned, you're required to calculate this hypotenuse value. So I'm going to be using the Pythagorean theorem over here. So h squared equals to opposite square and adjacent square is going to be h equals root of 4.3 squared and 2.5 squared. I'm just going to be plugging in the values directly in the calculator without wasting any time. I don't think you need another explanation on this one. It's quite simple. To be honest, the value for the displacement is going to be 4.97. So I would write it as 5 meters. So that's going to be my values for the displacement as well. So pretty simple. Again, if you look at the projectile motion required to calculate this displacement, so I just use the vertical and horizontal plane and use the Pythagoras theorem to calculate the displacement. Okay. By considering energy, calculate the speed of the object just before it lands. Very good question. So, what this question came up in the topicals as well. A very similar question. So, we always remember if we are like required to calculate the speed of the object just before it lands, the equation always goes like this: that initial kinetic energy plus again the object is going down, so the loss in gravitational potential energy will also be adding to the kinetic energy. Initial kinetic energy plus loss in GPE because the object is going down. So initially it has a kinetic energy. Since the height is going to be decreased, that gravitational potential energy is going to lose. Where would that GPE go? It would convert into kinetic energy. So that is going to be equal to the final kinetic energy. So there are two things to remember here. Because of no air resistance, since there is no air resistance, initial kinetic energy is not going to be lost in any other form. Initial kinetic energy, and since it had a height, so it already had a gravitational potential energy stored in it. So initial kinetic energy plus when it goes down, the gravitational potential energy is also converted to kinetic. So initial kinetic energy plus the loss in gravitational potential energy, both combined would be equal to the final kinetic energy. Plugging in the values, if you look at the question, I haven't seen mass anywhere, and the reason is that because mass is going to be on the both sides of the equation and it would eventually cancel out. So half m, initial was 6 squared, plus m, gravity is 9.81, and the change in height is going to be 2.5 because that's the change in height, is going to be equal to 1 over 2. Mass is again m, and the final velocity you require to find out. So mass cancels each other. 36 over 2, so 1 over, just let me just plug this in a calculator. This side, half times 6 squared, and then add it to 9.81 times 2.5. So over here I'm gonna get as 42.525, times it by 2 and root the thing. So times it by 2 and root the thing. You would get the speed as 9.2. So the final speed is going to be 9.2 meters per second. So that is going to be question number 2. It's a good question. Relatively, this paper is interesting. We have done 2-1 and 2-2, but this one's the best. All right, question number 3 then. Looks a little challenging. First of all, in the first part, they're asking you to state the Hooke's law. So Hooke's law states that force is directly proportional to extension. So force is directly proportional to extension within the limit of proportionality. Directly proportional to extension within the limit of proportionality. Okay. All right. For the next one, they're saying that the variation of the applied force with extension of the sample of the materials is shown in figure 3.1. The sample behaves elastically up to an extension of 80 millimeters and break at point X. So till 80 millimeters, the sample behaves as elastic. Okay. On the line in figure 3.1, draw a cross to show the limit of proportionality. Label it with a P. On the line 3.1, on the line in figure 3.1, draw a cross. Show the elastic limit. Label this cross with letter E. Okay, very simple. So they have already told you that it breaks at 80. So there's a cross and you'll measure, put an E over it. This is going to be the elastic limit. Whereas this point here is going to be the point P. And why is that so? Because the graph is turning over here, it's not a straight line, so the directly proportional relationship is going to be ending at this point P, where in this point E, they have already told you that the elastic limit is going to be reached. So it uh, behaves elastically till 80, and after that, definitely it's not going to be behaving elastically, and eventually at X, it's going to be the breaking point. Okay, a sample in B has a cross-section area of 0.40 millimeters squared. So the sample in B has a cross-sectional area of 0.40 millimeters squared and an initial length of 3.2. Initial length of 3.2. For deformations within the limit of proportionality of the sample, determine the spring constant of the spring of the sample. Okay, within the limit of proportionality is quite simple. So for the limit of proportionality, the formula you can directly use F equals kx, or you can use the gradient for the force extension graph, whatever suits you. I'm just gonna be using the formula directly because the graph starts from the origin. It's the same thing. It's totally up to you. You can use the gradient. Definitely the gradient, the other points 0 0, so it doesn't really matter. So I'm gonna be using this coordinate where this is 44 and 4. So this is going to be my points 44 and 4. Since the values in millimeter, I would have to convert it in meters. Beware of that. So 4 is going to be the force, and 44 millimeter, so I would have to like convert it in meters, is going to be equal to the K. So 4 divided by 44 times 10 to the power of -3, I would get the value of the spring constant as 91 newtons per meter. Moving on, the Junction modulus of the material from which the sample is made. So Junction modulus is given by stress over strain. So stress over strain, you can either write it down FL over AE, that we discussed the formula in the lecture as well. So force is going to be 4 newtons. I'm using the same points. Length is initially as 3.2. Area is 0.40. Since it's given in millimeters squared, you have to convert it in meters squared times by 10 to the power -6. And extension, you already know that it's going to be 44 times 10 to the power of -3. So I'm using the same coordinate that I used just right now. So I'm just going to be plugging in the values. So all right, so division 4 times 3.2, and then 0.40 times 10 to the power of -6, and then you have to times it by 44 times 10 to the power of -3. Your value is going to be a very big value, and that's a really big value. So I'm getting as 7.3 times 10 to the power of 8 pascals. Okay, that's good. Very good. Okay. Determine an estimate of the work done of the sample as it is extended from the zero extension to its breaking point. Explain your reasoning. Work done on the sample as it is extended from zero extension to its breaking point. That's a good question. So you're required to estimate the work done. Okay. Yeah, I just got the no. For a force extension graph, we discussed that the area of the force extension graph gives us the elastic potential energy or work done. We can call it both. So basically, you're required to calculate this area under the graph for the whole thing. Definitely making shapes out of it is quite difficult because it's not a straight line. I would recommend to make a trapezium out of it. That's going to be much more feasible. This trapezium I'm using over here, like till the elastic limit, these two, this and this area would definitely be a little bit equal. The answer is going to be in the ranges. So whatever suits you, you want to make different shapes, you can do that. I personally recommend to make a trapezium because the time is very important thing. Can't waste it. So just we have very less time in the paper. Trapezium is much feasible. So this point over here is going to be 4.8, I guess. Yeah, 5.4. 5.4, 5.6, 8, 10. Okay, yes, 5.4. And the second point, that's the, again, this point is going to be 6.8. And the height is going to be 192 times 10 to the power of -3. So using the trapezium formula, 1/2 Since you are required to give the reasoning, you can say that work done is going to be is equal to area under force extension graph. Force extension graph. That's going to be your reasoning. So trapezium half sum of parallel sides is going to be 5.4 and 6.8. 5.44 plus 6.8 times the height is going to be 192 times 10 to the power of negative 3. I'm just going to be using the trapezium formula. You can say the formula as well. I'm not doing it right now. Plus 6.8, and then eventually you'll just multiply it by 192 times 10 to the power of negative 3. The value I'm getting is 1.17. So 1.17, 1.2, whatever suits you. Okay. Last part states that a second sample of the same material has a larger cross-section area. So there's a second sample of the same material that has a larger cross-section area than the original sample, but the same initial length. Okay. The two samples are each deformed with the limit of proportionality. Okay. State and explain quantitatively how the spring constant of the second sample compares that of the original sample. Quite simple. Definitely, if the cross-section area is increased, so the extension would be less. So initially, you'll write that since area increases, or you can write it like cross-section area increases, extension is less. Why is extension less? There are two ways to describe that. Since the stress is equal to force per unit area, and if you increase the cross-section area, definitely the stress would reduce, and eventually the strain would reduce as well. So it would have to experience less stress. So cross-section is, since cross-section area increases, extension is less because of less stress. And lastly, you can state that spring constant would be more, because the spring constant is force per unit extension. So force per unit extension, definitely more force would be required in order to extend it. So spring constant would be more as requirement of force is more. I've written it a little bit detailed. Yeah, you can refer to the mark scheme to formulate another answer if you wish, but that's what I think is going to be the correct answer. So this is going to be question number 3 over here. Moving on to question number 4 now. Right, question number 4. The progressive wave traveling from left to right is shown at the instant in time in figure 4.1. R and T are the points on the wave. State the phase difference between the points R and T. So again, if you look at it, the one complete wavelength has a phase difference of 360 degrees. This is basically 3/4 of the wave. So this is going to be 270 degrees. So 1 lambda has a phase difference of 360. Half lambda has a phase difference of 180. 3 over 4 lambda has a phase difference of 270 degrees. That's pretty common knowledge. Okay. On figure 4.1, draw an arrow at point T to show the direction of the movement of the point T at the instant shown. Okay. So since the direction of travel is to the right, that means the direction at point 3 movement would be downwards. So from this trough till crest, all points always have the direction downwards. So the direction is going to be downwards. From to crest till trough, the direction is upwards. So it always goes like this. Moving on. Just required to make one arrow over here. Okay. The horizontal distance between R and T is 0.62 centimeters. As shown in figure 4.2, the speed of the wave is 0.27 meters per second. Calculate the frequency of the wave. So V is equals to F lambda. Speed is given as 0.27. frequency is unknown, and you're required to, okay, for the wavelength, they have given you this distance between one crest to the, yeah, they've given you 0.75 lambda as 0.62. So the whole complete wavelength is going to be x. We would just cross multiply that. So 0, you would get the wavelength as 0.826, so 0.83. And since it's in centimeters, you would have to convert it in meters as well. So 0.83 centimeters is going to be the whole one complete lambda. Okay, so 0.27 you're divided by 0.83 times 10 to the power of -2. You would get the frequency as 32.5 hertz. Eventually, you'll have to like convert it into significant figures. So 33 hertz would be the frequency. Moving on, the wave is a water wave produced by dipper S1 attached to a vibrator in the ripple tank. The identical dipper S2 is attached to the same vibrator. The two dippers produce an interference pattern on the wave in the tank as shown in figure 4.3. The wave crest from each source are represented by solid lines on figure 4.3, and the wave troughs are represented by dashed lines. At point P in figure 4.3, the wave S1 and S2 have the same amplitude. Describe and explain the amplitude of the resultant wave at point P. That's an excellent question. Okay. So if you look at point P, at point P, like the waves are out of phase. They're both out of phase. So they would show destructive interference. So destructive interference will be there because definitely the crest is meeting to the trough. So there's going to be destructive interference. And yet again, since they have same amplitude, they would be showing that no resultant amplitude will be there, and eventually the resultant amplitude will be 0. So I would answer along these lines. At point P, waves from S1 and S2 meet and superimpose. Since resultant amplitude is sum of individual amplitude, and at point P there is destructive interference. Why is there destructive interference? Because the crest is going to meet to the trough. So there is destructive interference. Hence, resultant amplitude is 0. So the wave with amplitude A meets with the wave with amplitude A, and then they superimpose. Eventually, there's going to be 0 amplitude, and there won't be any amplitude. Going to be like both would destruct each other. That's going to be part D, and that's it for question number 4. All right, question number 5 states that state Kirchhoff's second law. So Kirchhoff's second law states that some, yeah, you can say starting from in a closed loop, sum of all EMF is equal to the sum of potential difference. State the conservation law that gives rise to Kirchhoff's second law. Okay, this Kirchhoff's second law is basically related to the conservation of energy. So conservation of energy, it's always conservation of energy because voltage is energy per unit charge. So it's related to conservation of energy. Okay, a circuit contains a cell of internal resistance R, and the two resistors of resistance R1 and R2 shown in figure 5.1. The potential difference across the two resistors is V. So the potential difference across two resistors is V. The current in the cell is I. Use Kirchhoff's law to show that the total resistance of the external circuit is given by this equation. Excellent question. The similar question, very similar question in the series came up in the other paper of May-June 2024. So yeah. So again, you can say that the current total is going to be equal to the current in I1 and the current in I2, because current entering the node is equal to the current exiting the node. So I1 is going to be dividing into I1 and I2, sorry, I total is going to be dividing into two parts. So from that, I can say that since V equals IR, so V over I is going to be equal to, sorry, V over R is going to be equal to I. In parallel circuits, since the voltage remains same, I do not need to write like Vt and V1, V2. Rather, I can just substitute it as V over R total is going to be equal to V over R1 plus V over R2. V would cancel each other, all the V's would cancel each other out, and we would be left with 1 over R total is going to be equal to 1 over R1 plus 1 over R2. That's going to give me 2 marks very easily. Moving on. The electromotive force of the cell is 1.5 volts. When the values of R1 and R2 are 10 ohms and 15 ohms respectively, the potential difference measured by the voltmeter is 1.38 volts. So the potential difference measured by the voltmeter is going to be 1.38 volts. Calculate the internal resistance R for the cell. Okay, that's pretty good. V equals IR. So if you look at the EMF and the terminal potential difference, that's 1.38. So the battery is itself consuming 0.12 volts. That's what the battery is consuming by itself. So 0.12 is going to be equal to the I, that's the current that we do not have. So for calculating the current, very similar question to one we did in the previous question paper of May June 2024. You can use V is equals to IR. In place of V, you can say since the voltage is 1.38, you're required to calculate the current, but the total resistance of these two is not going to be 10 plus 15, rather it's going to be 1 over 10 plus 1 over 15, and you inverse that. From there you'll be getting the value of the current. So 1 over 10 plus 1 over 15, inverse it. So you're going to be inversing that, and then 1.38 divided by the answer to that, and you'll be getting the current as 0.23. So the current is 0.23. Current is going to remain the same. This is the total current because I use the total resistance. So 0.12 divided by 0.23 equals equals R. So 0.12 divided by 0.23, the value for the internal resistance will be 0.52 ohms. That's going to be the internal resistance as 0.52 ohms. Moving on. A third resistor is added in parallel with R1 and R2. So there's a third resistor that is added in parallel. Okay. If another resistor is going to be added in parallel, that means it would reduce the total resistance. Okay. State the effect. State and explain the effect, if any, on the change in the current. Definitely, the current would increase as the resistor R3 is added. The combined resistance would reduce. So combined resistance will decrease, hence total current would increase. Moving on, the PD measured by the voltmeter. Okay. Again, because the total resistance is going to decrease, the potential drop would also decrease, less requirement of voltage would be there. So PD would decrease as resistance decreases. More voltage will be consumed by internal resistance. So the answer goes along these lines. That's pretty much it for question number 5. Guys, last question for this exam paper is question number 6. The nuclei of an isotope of samarium each contains 62 protons and 85 neutrons. State the nuclei notation in the form of this for this isotope of samarium. So again, the X samarium is Sm, so yeah, Sm, and definitely the mass is going to be 62. plus 85, you would add the protons and neutrons, so 147, and the proton number is going to be 62. That's the first part. The isotope of samarium is radioactive and decays by emitting particles. Gamma radiations is not emitted. The energy spectrum of the emitted particle is shown in figure 6.1. Explain how figure 6.1 shows that isotope of samarium emits alpha particle and does not emit beta particles. So one thing to remember over here, that beta particles, we already discussed that in the previous paper as well, that beta particles has range of kinetic energies, whereas alpha only has one kinetic energy for as many number of particles. So if you increase the number of particles, the alpha particle has the similar kinetic energy. That's discrete. So again, the answer is going to be along these lines, that it emits alpha particles as according to the diagram, to the figure 6.1. there is only one kinetic energy. Beta particles, on the other hand, has range of kinetic energies, hence it cannot be beta. So there's a key point to remember over here, that beta particles has range of kinetic energies and alpha particles only have one kinetic energy. Alright, the isotope of samarium decays into the isotope of neodymium. But I don't know what that is. Give the radioactive decay equation for this decay, include the nucleon and proton numbers of all the particles involved. Okay, so there's going to be an alpha decay. Okay, so there's going to be a particle that's SM17762. SM147 and 62 decays into Nd, and then an alpha particle that's 42. So 147, that's going to be 143 and 60. That's the equation. Okay. A baryon is comprised of three quarks which all have different flavors. The baryon has a charge of 0. Two of the quarks in the baryons are an up quark and a bottom quark. Determine in terms of elementary charge the charge on the third quark in the baryon. Okay. So the baryon has an up quark and a bottom quark. So up and bottom. Okay. So the final charge is going to be 0. The up quark is 2/3. The bottom quark is -1/3. There's going to be another quark x, and that eventually end up being 0. So charge is going to be -1/3 E. So eventually you'll just add them up. So you'll be left with +1/3 plus x equals 0. So x is going to be equal to -1/3 and -1/3. So it's -1/3. So again, it can be a bottom quark. So because bottom quark has a charge of -1/3. So that's pretty much it for the whole exam paper of May-June 2023, paper 2-3. Thank you.